So we are talking about how to use some, come on, dude, rate law equations. How much of a compound is there over time is really what we're after. And we'll have to review some algebra to get there, and we'll do that. And then and that's where the most of your homework is going to come from. But then there's going to be a few of these problems where you have to actually draw the energy of a reaction. How does the energy change from reactants going to products? And we'll talk about that too, but that won't be no algebra there. So what's the big deal with all this stuff? Well, I would say here's a big one, right? With all these drugs, we're a well-drugged society, right? And how much of this compound, what's your dosage over time that you're actually getting, time release for those drugs? Or just simply, how long will this guy last outside, whatever this little doohickey is outside, right? That time is an important factor in a lot of reactions. Some are going to go really slow. How long can you expect something to last? Or after 10 seconds, what's going on? Okay. And these are really complicated potential energy plots. And this is you're never going to, computers handle all that for you. And that's kind of like a physical chemistry sort of thing. But that's our potential energy. And all they're changing is, what are the different orientations of that molecule, or one reactant approaching another? How does the energy change? So that's what those plots are. But don't worry about those. Ours are going to be a lot simpler than that. So here's our kinetic equations. So kinetic means time, so time has to be in there. And we've got 3 first order, second order, 0th order. Well, if time's got to be in there, what little symbol is probably going to be time? Yeah, a little t. Now, a little t is showing up in a lot of places. And remember, whenever you have brackets, Alyssa, whenever you have brackets and you stick this chemical in there, right, what are those brackets supposed to be telling you? They're really referring to what? Oh, it's brackets. So that's supposed to be, starts with a C, concentration. That's supposed to be concentration. So you see it in here a lot. And that makes sense, I think, because this is supposed to be how much stuff do I have after 1 second, after 10 seconds, after 20 minutes? How much of the stuff do I still have? Okay, that hasn't reacted yet. So that's what these equations are giving us. So the equations only work, though, for this very limited range of reactions. So pretty much you have one reactant and it's pretty much just falling apart on you, right? And that little a is the what do we call it? The stoichiometric coefficient, right? That's a little guy to make it balanced. So A is our compound. So we have these reactions in their first order, second order, 0th order. Remember the order idea? What was order? Cameron, what was order again of a reaction? It had to do with rates. You added up the what to get the order of that reaction? Added up the little, does anyone remember? The exponents, right? So you add up the little exponents and you get a 1, it's first order. You get 2, well, it'll be second order. You get 0, it'll be 0th order. So that's what this is really messing with. Okay. So there is no third order. We don't have any equations for that. But do you recognize K? Andromeda K is in there. You see it? What's that little K? What do we call it? The rate constant. So we've seen that before. Okay. Mia already said, Megan, that T was time. So we got that one covered. How about this bracket A with a little subscript T? We see that in a lot of places here. What is that? What would you guess that is? It's in brackets, so it's got to be concentration of that compound after so much time, right? 10 seconds, whatever they say little t is. So if t is 10 seconds, well then the bracket A with sub t will be the concentration at 10 seconds. Okay, after this thing is started, 10 seconds later. Okay. There's only one left, Andrea, that we have not. Oh, no, there's two left. Let's talk about this one. There's no little t on it. There's a little 0. So that's probably what? That bracket A with a little 0. The initial time. They're already getting lazy. Shouldn't they have wrote t equals 0? Would have made more sense. But they have little 0, and that's the initial time. So that means that, okay, how much did you start out with? We started out with 2 molar. Okay, well, that's concentration of A at time 0. So there's going to be a concentration, the initial. And we have one left, T sub 1/2. T sub 1/2, Connor, what is that one called? Half-life. And we'll talk about that one a little bit. Just remember, T1/2 is a time, and it's half-life. And we'll talk about what that means later. So let's worry about all that stuff later. Let's figure out this algebra first, because we're going to be playing the same game as always, right? Let's just pick this middle one. I see 1, 2, 3, 4 variables in there. That means, Jose, if you ended up using this equation, you've got 4 variables, and they're going to have this big wordy problem, and the big wordy problem is going to give you how many of those variables? If they give you 4, there's nothing to solve for. They're going to give you, they have to give you 3, and you solve for the 4th. If they gave you only 2, it's impossible to solve. All right? So they have to give you 3. So they'll give you 3 of them, you substitute them in, and then it's always going to look like this. I mean, you just got to pick the right equation. So they're going to have to tell you first order, second order. They have to tell you that stuff. And then I give you these equations, and then you just plug it in. So it's going to end up looking like one of these things. So let's let Kenneth tell us how to solve it then. Look at this first one, Kenneth. Right? It looks like this one is which equation?
The first one.
Yeah, I think he's right. Right? It's substituting into this first one. It's a first order. How would you solve? We're solving for what variable in there, Carmen? Or Cameron? We're solving for time, that little t. So Bounty, what are you going to do first to solve for little t in this thing? You plug it all in, you know, you have it all typed out, and what would you do first? She says, what's the ln part? Natural log. Is it on your calculator? Yeah, I better turn on the lights or these things aren't even going to work. Well, first let's figure out how you're going to do this in the calculator first. What would you do first? Anyone see what to do first? If you can do it all, imagine, again, the big goal is to handle these without writing anything down. If you write this out on the quiz or exam, you're showing your work is done. What I'm really hoping is what I see is t equals this with a box right under it. The frustration level goes down, everything goes down. So how would you go from here to here? So in your calculator, you do what first?
6.3.
Yeah, take the 6.3 times 10 negative 3, divide it by the 3.9 times 10 negative 2. Hit equals. And then take the natural log. So push the ln button. And then divide by a negative 89, you'll have your answer. So try it. Do it in that order. So you look at them and see if you can figure out what to do first, second, third. So I would handle what's in the natural log first. 6.3 times 10 negative 3, divide it by 3.9 times 10 to the negative 2. Take the natural log, there it is. Divide it by 89 negative. How do you make the negative sign? Use that little plus minus button, right? Did you get an answer? Enrique, did you get an answer? What did you get? 0.020. Perfect. Okay. So this is a big exam question, Audrey, and you write 0.02, but you didn't write any units, you lose a point. What units do you guess you got to put on there? Seconds. Seconds. Okay. How about these? Oh, we're going to solve for it. We'll find out in B. We're solving for the bracket guy in B. Okay, Kendall. Kendall, did you get it? Okay. How would you do? Okay, help her out. Let's pick somebody else here. Kendall. Alyssa. You didn't get it? Okay. To take the 6.3 times 10 negative 3 first. Right? You know how to get that in the calculator? Use the EXP to get 10 negative 3. Divide it by 3.9 times 10 negative 2. And then hit equals. And then ln. And then divide by 89 negative. Mia, did you get it? Did you get it? Show her how to use it then. Audrey, show them how to get it. Here's another one on B. See if you can figure out how to do B, then I'll ask somebody. Again, see if you can do it in one step. But this one might be a little bit harder to do in one step. But it's possible. Anessa, what would you do first in solving this B?
I kind of write it out, but I can do it all in one step. So the first thing you have to do is you have to put everything e to the power. And
yeah. To get rid of that ln, you have to raise both sides to the little e. That's the thing you got to remember. So I would take the negative 35 times 5, get an answer there, then raise it to the little e power. Right? So you might want to write stuff out on this one. Raise both sides to the little e power.
you get e to the negative.
Right? And then you get 2.49 times 10 to the negative 5 over A0 equals e to the negative 175. Holy cow, really?
Yeah.
All right, well, we need a number for that. 35 times,
How do you get the number for that?
shift e to that power. 9.96 times 10 negative 77. Okay, so make sure you can get this far. All right, everybody get this far? All right, Steph, did you get this far? Okay, how do you put the E? You find the, there it is, it's orange. It's right above the ln. So you have to take negative 35 times 5, get an answer, and then push shift e to the x. Okay, and then you've got this number. Okay. Now what do you do? Again, this would be nice to have one step.
Couldn't you do it in one step without doing it?
Okay, now everyone's this far though, right? Let me just show you how I handle this kind of stuff. How I handle this stuff is I've got this in the calculator, right? So what I'm going to do is this has to go on the bottom, A0 goes up on top. Does that make sense? So what I'm going to do is, since this is 9.96 times 10 negative 77 is already in the calculator, I'm going to push shift 1 over x and flip it. Right? And then take it times this guy, times 2.49 times 10 to the 5 negative, and I have my answer. 2.49 times 10 to the 71. Okay. Man, I got to work with these numbers. They're kind of way off, but we're messing with math, so it's okay. Okay. So if you don't like that, just bring this down here, write it out again. Bring the 9.96 and 10 negative 77, bring it down there. The A0 up on top, divide the two. Okay. Mm-hmm. Yeah, I don't care. Just the fewer steps that you need to do to get this far, the healthier it is.
Okay.
Mm-hmm.
The same answer.
Do the last part again? So like where you do the
So take, remember this has to go up here, that has to go down there. So take 2.49 times 10 negative 5, divide it by 9.96 times 10 negative 77.
and then you do the 1 over it.
It's how you want to do it. If you, right, depends on how you want to do it. Just make sure you get, this is the final answer. What units do I put on there?
The
Big
big M.
M. Big M. Right. All right, see if you get numbers for these. This is where I think this is where all the trouble is in the algebra. That's why we're spending so much time on it. Right, Mia? See if you get numbers for these. And again, if you can do it in one step, great. If you have to write stuff down, fine. But the less you write down, I think the healthier it is. Everyone, you gotta make sure you bring a calculator. How would you handle C? Right? It's 12 times 18 plus 1 over 2 times 4. 1 over 2.4 times 10 negative 4. What I would do is I'd handle this part first. Just take 1 divided by 2.4 times 10 negative 4, then plus 12 times 18, because the calculator knows to do multiplication before addition. Hit equals, and then just do the 1 over x button, because that'll flip it. That's what I would do. I would take, you can even do plug in 2.4 times 10 negative 4, and then push the push the 1 over x button. That'll flip it. Plus 12 times 18, hit equals, and then do 1 over x again and flip it, and you'll get an answer. So I got about 2.28 times 10 to the negative 4. Make sure you can get that. So I put in 2.4 times 10 to the negative 4 in the calculator. I push the 1 over x button, plus 12 times 18, hit equals, push the 1 over x button again, got it. Enrique, did you get an answer for D? Okay, try D. Anybody having trouble getting C, just let me know so I can help you out. This is the hurdle I think we have to overcome. Did you get an answer for that?
Just multiply this over it.
Let's see. It's in the side of the ln. So you have to take this times that, raise it to the e power.
I did that.
Okay. And then you take it times that. Exactly.
What's up at this point after I do the whole E thing?
And then you got to take it times this. So you just move up to the top.
Stop. Which one's after what? This times that?
Right? Because he's on the bottom.
Yeah.
He's on the top. You want to solve for this one. So to move this over to the other side, it has to go to the top.
Yeah. Just multiply this.
Yeah, so find out what this is and get your answer in the calculator. And then take it times 7.2 times 10 negative 3.
Okay. I already did that. Just making sure I was doing it right. Thanks.
How do I get to this?
Okay, so here I would do this part first, raise it to the e power,
Okay.
and then take it times the 7.2 times 10 negative 3, because it has to come up to the top. Anybody get an answer for D?
17.
Times 10 to the negative 3. Perfect. You should get 2.17 times 10 to the negative 3. Don't forget units. So in D, take the 8 times 0.15 negative, get an answer, raise it to the e power, and then multiply it by 7.2 times 10 negative 3. Okay. Does it work, Megan? Okay. Half-life. So we're good? No one has any questions on that algebra stuff? Half-life. I wonder if this sounds familiar to you. Sound familiar? From the movies? Oh, what is it? This is a Geiger counter. Detects radioactivity, right? And I remember seeing the movies like Half-Lives and things. That's what this is. It's half-life. All it is how much time does it take for this beeping to get cut down to half as fast as it's beeping right now. So you want half the stuff to go away. Because radioactivity, right, it decays over a while. It's going to take a long time, but it will slow down. How long is it going to take for half of this beeping to go away, right? So the rate is half as much, half as fast. That's half-life. Okay, and there's a trick to answering these. Okay. You start out, because that's A0, you start out with 4.9 molar. And they're saying the half-life is 5 seconds. So what is the concentration of A after 5 seconds, 20 seconds, and 30 seconds? Now this trick always works when you recognize what's going on here. Do you see that? These are all multiples of half-lives, right? Like in number 1, how many half-lives went by? 1. In number 2? 4 half-lives. And Steph in number 3? 6 half-lives. So everyone see that. Okay, so this is the only time this trick is going to work. Otherwise, we're going to have to use these equations. Okay? But really, how many half-life equations are there? Kendall, how many are there? 3. So they have to, if you're not going to use this trick, they got to tell you which one you're going to use. Oh, it's 0th order, it's 1st order, 2nd, right? So if it's ever a half-life equation and they don't tell you what order it is, it's going to be this trick. Okay, what's the trick? You already told me how many half-lives went by. If it's 1 half-life, well then exactly half the stuff is gone. So 1 half-life went by, so 4.9 divided by 2 is 2.45. Thank you. 2.45 molar. There's my answer. Because exactly half of it's gone. Okay. In number 2, how many half-lives? 4. So you have to write a half 4 times, or just raise a half to what power? 4th. So 0.5 raised to the 4th power. How do you get raise things to the power on this calculator? You push what button? X to the y. So put 0.5, x to the y, take it to the 4th. You get 0.0625. So you have to multiply 0.0625 times that 4.9 molar. Before it was just 1/2 times 4.9 molar, because there's only 1 half-life. Now you have to multiply that initial concentration times a half 4 times. Okay? Because 4 half-lives went by. And I get, take that times 4.9. I get 0.3. And then to answer the last one, number 3, now I have to take 4.9 molar times 1/2 to the what power, Enrique? Take it to the 6th. So 0.5 raised to the 6th power times 4.9. Right, and Megan, what'd you get? 0.076. And what units, Kenneth, do I put on this stuff?
M.
Big M. So molarity, molar. Okay. So that's the trick to doing these. Figure out how many half-lives went by and raise 1/2 to that power. And then multiply it by your initial concentration. Okay? So that's the half-life issue. Okay, now we're talking about making these plots of a reaction. Reaction, they have a fancy word for the x-axis. They call it reaction coordinate. All they're saying is where is everything? Your reactants, where are they physically in space as they approach one another? And then you have potential energy on the x-axis, on the y-axis. So what is this stuff? This stuff is exactly what this is. Right? You got the little skater dude up on the hill. Okay. So what would be the best way to describe this, Kendall? Would you say, now, again, you start out with reactants, you end up with products. So the guy being at the top of the hill is the reactant, I guess, right? Would this describe an endothermic or an exothermic reaction? Exothermic, right? Because it's going to release all this energy. Make sense? Okay, so this is the answer. This is what you have to draw. Now, I drew these nice curvy things so the guy hopefully won't go flying off, but this is what your plot's going to look like for exothermic. Right? So exothermic is over here. So potential energy, and they're going to want you to draw this stuff. So this is what we do then. So you draw something up here. You have to have a little hump. Go down there. They want A plus B written over here, because that's my reactant. And then, Andrea, what do I write here as my product? Big C. Okay. So the idea here is why have that little hump? They call that the energy of activation. That it has your reactants, and they always have a little hump before the reactants. There's always a little hump for the reactants to overcome, because they just don't instantaneously happen. They need to have some minimum energy, and that's why there's this energy hump. Okay. Well, I could speed him up by increasing his temperature, but I don't think I can do that. So I could just lower the hump a little bit. And there, right? Oh, he's off the planet. But that's the idea. Okay? So they want us to label a few things here. They wanted us to label energy of activation. Okay, well, remember, that's the size of your hump that the reactants have to overcome. They wanted us to label enthalpy. Remember when we had, you have a reaction, and then you have delta H equals so many kilojoules per mole? That's what they're talking about. It's that same delta H. So it's just the difference in energy between the reactants and the products. So kind of sketch that out. You can make it red if you want. Right? There's my delta H. So that's exothermic. Now they just want us to draw the same thing for endothermic. Okay? So endothermic, start with your reactants, end up with your products, right? Because now you have to end up at a higher energy, because it's supposed to be endothermic. Okay? The dude ends up going up the hill and staying up there. He takes all this energy to get there. But remember, there needs to be a hump they have to overcome. Okay? So things just, there's always a little hump. So there's endothermic. So how do we sketch in our energy of activation? There it is right there. Whoa, it's going to be a little bit higher than that, isn't it? Oh, it's all the way. Those reactants need a lot more energy than that. They have to start way down here. So EA is always the energy that the reactants have to overcome. So it's huge for endothermic. And then enthalpy, you just kind of draw a line between the reactants and the products. And that's your enthalpy. So when they ask you on the quiz or exam to draw a potential energy diagram, it's going to look exactly like this, except you just change A plus B for your reactants and C for the products, depending whether it's endo or exo. It's going to look just like this. Okay? Does that make sense? Okay. I think this is where all the homework is, right here. This, I mean, there's going to be a few on the other ones, but this is where all the work is. So, Enrique, I saw that at second order, so I went before class and I copied and pasted the appropriate equations in, because I give you all that stuff, so I just copied and pasted it over. But what variable are we going to solve for? We're going to substitute everything in, but which one of those are we going to solve for? A subscript 0 or A subscript T? Right? Yeah, because they're asking for what is the molar concentration of A. So you know it's got to be one of those two. Which one is it going to be? T. It's going to be the one with the A subscript T. You got to find that one. That's the one you're after. That means they had to have told you everything else. So you just substitute it all into that equation, make sure they're all in the right units, and they always are. I think the only thing they're going to mess with you on is the time. I think that's the only part where they're going to say, just make sure this is in seconds before you substitute it in. Then you're good. The homework, I bet you might say an hour or 20 minutes or something. Just convert it all to seconds before you substitute it in. So substitute what you can find into that equation. You should have something for everything but A at time t, and then solve for it. Should work. Right, so remember, I would get a number on that right-hand side and then just push the 1 over x button to get your final answers that I would do. So I would get a number over here in the calculator and then just do 1 over x in the calculator, and you'll have your answer. Alyssa, did you get an answer? 0.088. Anybody else get 0.088? Andre did. Audrey did. 0.088. good. All right, but you're going to lose a point, Kenneth? What units?
M.
Big M. Good deal. Try this one. Oh, hey, before we go on, it's always good to look at this because it's easy to screw up in the math. Does the answer make sense? I mean, is it plausible? You started out with 0.293. Your answer just has to be bigger or lower than that. The answer has to be every single time lower, right? And it's lower, so I guess, right? That's what I would do. Try this one. So again, they said it was first order. That's why I copied and pasted those equations in. Whoa. Whoa, this is a good one. They said initials here. Did you get this far? All right. Hopefully you got this far by reading the question. This is what we got to solve. All right. The T is 750 because they want to know the concentration at 750. So I got to have the 750 in there. I'm going to solve for that guy. Here's my initial, but I'm missing K. So what do I got to do first? This is the two-part question. Do this part last. First, do this. Well, this, fine. Find K. All right? Because look at that. Notice how they gave you 2 times. So in that one where they gave you the 450, at 4:55 seconds, they told you everything but K. At that 4 and 55 seconds, they told you the initial was 0.0015. They told you it was 0.00119 at T. So you got to find K first using this data. Then whatever you get for K, you plug it in over here to get your final answer. Okay, so you have to use that same equation twice. You have to use that same equation twice. So I would do what's inside the natural log first, right? Take that 0.00119, divide it by 0.0015, get a number for that, then take natural log, then just divide it by a negative 455. And you'll have your k. You'll be good to finish it. Did you get 5.09 times 10 negative 4 for a k? Yeah, good deal. So use that for your k now over here. Get an answer here. About 2.19 times 10 to the negative 3 is what I got. Is that possible? That was your, I think I screwed up on that. What did you get?
1.024 times 10 to the negative.
750.
Sir,
Yep.
what did you say you got?
I don't know. I screwed up, I think. Oh, it's negative. I forgot my negative, stupid negative sign. Right? That'll really help.
I got that first, but like if you do it again, you just have to like make.
So you got 1.02 times 10 to the negative 3? Yeah, I forgot my negative sign.
You just have to put it in order.
All right. So you go here, you get down there.
How much are you taking off if the answer's wrong for the worst, right?
Good question. I don't know. Probably a lot. I don't know.
Come on, we're on the right path.
So, because the hard part isn't really picking the equation. The hard part isn't substituting it in. The hard part is going from here down to there and getting your answer. So it's not a typical type of question there. So combined, I'll be glad to work with these.